So let's do this ch12 practice test. So first problem, we want to find the equation of this. So I already told you it's cosine, but we got to find, remember when we do these, I always like to find out what c is first. You got to figure out what the middle is. The easiest way to do that is you take the max plus the min and divide by 2. That's how I find the middle of anything. Just max plus min divided by 2. So my max here looks like it's 5. My min is -3. If I add them up and divide by 2, I get 1. So that's my middle. And that's the key to everything. If you do that, then the next part's easy. If you want to find the amp, remember amp is just from the middle to the highest point. So from 5 to 1, and that would be 4. And then B never changes. It's kind of weird, but it's one that never changes. You gotta find the period, right? Period equals 2 pi over B. So you gotta find the period of this guy. Now again, start at the start. Do one full rotation. And it looks like you stop at 4 pi. So that's my period. Period equals 4 pi. So 4 pi equals, we're running out of space here. So 4 pi equals 2 pi over B. Cross multiply. 4 pi B equals 2 pi divided by 4 pi. And I get B equals 1/2. So there's my answer. Y equals 4 cosine of 1/2 x plus 1. If this cosine was upside down, it would be a -4. And that's all the same. Rewrite each degree measure in radians and write each radian measure in degrees. So we have to convert these. So the way you convert, if you want to go from degrees to radians, you multiply by pi over 180. Right? I always think about like degrees doesn't have a pi, so I need to get the pi. So it's pi over 180. And we get 325 pi over 180. And I guess I could divide that by 5, but I don't have space. I'm gonna leave it like that. The next one, let's convert this radian to degree. Notice it has a pi, so I know it's in radians, so I want to go to degrees. So we're going the opposite way. So we just flip it. So we're going to multiply by 180 over pi. I always think about it, I want to get rid of the pi I have. So that means pi has to be on the bottom. These will reduce. I could reduce 4 and 180, that's 45. That's mean 9 times 45, which is I think 405. I think that's the right answer. Find the coterminal angle of each thing. So remember, it's all about definition. Coterminal angle just means add or subtract 360. It means the exact same angle, just you go around in a full circle. So all you have to do is add or subtract 360. So this one doesn't say, I'll just add 360 because a lot of times it's a lot easier. I always like to add instead of subtract. I get 8, so 685. So what's going on here is that this angle, 325 and 685, has the same reference angle. If you would draw it, it'd look at the exact same position. Next one, it's in radians, so 360 doesn't work anymore. I guess I can convert it, but it's too much work. Instead, 360 in radian is 2 pi. So plus or minus 2 pi. And we just do common denominator. So that would be 8 pi. And I get 9 plus 7 is 17 pi over 4. I guess I could also subtract it, and I think I just got 1 pi over 4. So again, lots of answers here. Same thing here. I could have subtracted 360 if I wanted to. And I'd still get a coterminal angle at -35. So either one of these is okay. Same thing here. Terminal side of an angle in side position contains a point 68. Find the exact value of the 6 trig functions. So I'm going to do all 6 trig functions here. So let's try 6, 8. So you go over 6 and then you go up 8. That's the idea. Like 1, 2, 3, 4, 5, 6, up 8. Now we got to draw a triangle here, and it's always drawn the same way. You go to the origin and to the x-axis. That's how we always draw our triangles. Now we went 6 this way, so this side is 6, and we went 8 up, so the height is 8. Now we got to find the hypotenuse. Well, it's a squared, b squared, c squared. Now 6, 8, you should know this triangle by now. It's a 6, 8, 10 triangle. You could do it if you want me to do it. But you should know 3, 4, 5. That's always a triangle. 6, 8, 10 is always a right triangle. There's 5, 12, 13. It's a little fancier. And then all the ones we know. So like 1, rad 3, 2, 1, 1, rad 2. Those are all like right triangles you should kind of memorize, especially these two. You see these a lot. 36 plus this to prove my point. So 100 equals c squared, square root, c equals 10. So 6, 8, 10. Again, this is my angle. And now we all gotta do is SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So sine would be opposite over hypotenuse, 8 over 10. You can reduce if you want. I'm just gonna leave it. Cosine. Now notice it's cosine theta. You don't supposed to put cosine. It's cosine of an angle. Like this doesn't make sense. It's sine of something. Anyway, back to the problem. Cosine theta adjacent over hypotenuse, 6 over 10. And then tan TOA opposite over adjacent, so 8 over 6. Again, you can reduce them. I'm just gonna leave them though. And then to do the other three, the reciprocal function, you just got another reciprocals of each one. Sine goes with cosecant. A lot of people get that confused. I think it's the opposite of what it sounds like, or what you think. And likewise, cosine goes with secant. So that's a reciprocal. So just flip it, 10 over 6. Tan's the only one that goes the easy one, cotan. So just flip it, 6 over 8. And those are the 6 trig functions. My favorite part. Let's evaluate these trig functions. So cosine of negative 90. So remember, it's a negative, so it's going down and not up. So here's 0, here's negative 90, so we're right there. You're on the line. So remember, you're entering the line, you get into that point. This is 0, negative 1. Cosine to the x, sine to the y. So it is 0. Sine of 585. Now, if I give you a little hint here, find a coterminal angle. So you could do this, but it's a lot easier to find a coterminal angle. So let's just subtract 360. So I get 5, 2, 2. So it's the same thing as saying 225. So let's find 225. 0, 180, 270. 225 is in here somewhere. And we always do the same thing. Make a triangle, go straight up. Here's your angle. Forgot the reference angle, so this is 45. Know the side, so this is 1, 1, rad 2. I like to figure out that it's negative or positive. Since we went left, it's negative. Since we went down, it's negative. Hypotenuse is always positive. Then we do sine. So, opposite of hypotenuse. So, negative 1 over rad 2. Or if you want to rationalize, rad 2 over 2. If you do the table method, this is the one you see, negative rad 2 over 2. If you don't like doing the signs, you can always do all students take calculus. So it's right here, we're in quadrant 3, only tan is positive, so since we're doing sine, it's negative. Let's go to the next one. So now these are in radians. So radians are actually my favorite. I think it's a little easier if you have them all memorized. So 4 pi over 3. So here's 0, here's pi. I want 4 pi over 3, so this would be like 3 over 3. I could go a little past that, so it's going to be 4 pi over 3 over here. It's over 3, so I know it's 60 degrees. And then you just got another side. Now, 60 is the big one, so it gets to rad 3. Hypotenuse is always 2, and adjacent's 1. We talked about this before, but what's negative? Well, this is negative, because you went to the left, and then this is negative, because you went down. Hypotenuse is always positive. We're doing cotan. So just do tan and flip it. So TOA. So opposite over adjacent. So negative rad 3 over negative 1, which is rad 3. But that's tan. I gotta do cotan. So you just flip it. 1 over rad 3. Or if you want, rad 3 over 3. So there's that one. Next one, secant and negative 9 pi over 4. Now that's really big, so you could add a coterminal angle, but in my experience, most people don't like adding fractions. These are easy enough to just do by hand. So we'll do that. Here's 0, here's pi. Negative, again, we got to go down instead of up. So, yeah, remember, always use a trick. So this is over 4, so you want to make this 4 over 4. So we're going this way, we're going negative 4 over 4. I got to go away at 9 though, so 4, go around again, be negative 8 over 4. and then you gotta go a little past that, so it'll be in quadrant 4. Now again, remember, it's negative, so that's why we go down. So 4 over 4, and then we gotta go all the way to 9, so we go another 4 over 4, that's 8, and then we gotta go a little past that to go to 9. So quadrant 4, so over 4 is automatically 45 degrees. Opposite, it's a 45, 45, 9 triangle, so we have 1, 1, and rad 2. What's negative? Only going down is negative. We went to the right, that's positive. Secant's opposite of cosine. So let's do cosine first. So ga, so adjacent over hypotenuse. So 1 over rad 2. And then we're doing secant, so flip it, rad 2. Sine of pi over 2. So let's draw pi over 2. Here's 0, here's pi. Here's pi over 2. That point, remember, it's on the line. Anytime you're on a quadrant, quadrantal angles, anytime you're on the axis, sorry, quadrantal angle, you should know that point. It's just a circle. It's a normal XY chart, so you went up, so 0, 1. Right, it's just a normal XY chart. So 1 over, 1 up, 1 left, 1 down. And then sine E, sines of y value, so 1. Oops. This problem I actually forgot to erase. This is from 12.9, which we haven't done because of COVID. We're not going to be able to do because we don't have the time for it. So that you won't see it on the test. Sorry about that. Draw an angle measuring negative 80 in center position. So here's 0. Negative 90 will be over here. Remember, because negative go down, so it'll be over here somewhere. There's negative 80 degrees in center. Hand gliding. A hand glider climbs at 20-degree angle of elevation. Find the change in altitude of a hang glider when it's flown a horizontal distance of 60 feet. So the key here is angle of elevation. Anytime you see those words, you want to think, well, especially angle of elevation or depression, you want to think horizontal line. So you draw a straight line, elevation's above that, and a depression will be below that. So it's all based off the straight line. So that's the key. So anytime you hear angle, elevation, depression, draw a straight line. Elevation will be above it, depression will be below it. So here we have angle, elevation, draw a straight line. Here's 20 degrees, go to elevation. Find the change in altitude. Altitude is a right angle, so when you go straight down, that's the altitude. So altitude always should have a right angle. And of the hang glider when it has flown a horizontal distance of 60 feet. So horizontal is left and right, so this right here would be 60 feet. And we're looking for this guy. So it's just a normal trig problem. We have a right triangle here. So what do we have? We have this right here. So this would be opposite. This would be adjacent. So ch12 would be opposite and adjacent would be TOA. So tan of 20 degrees would equal x over 60. I'm not sure why I put a little degree sign there. I shouldn't have one. Then you just gotta solve for x. So let's multiply both sides by 60. So I get x equals 60 tan 20. And I can put that in a calculator. I don't have one on me right now. I'm kind of lazy to bring it out, but that would be your answer. Next one, it's a Ferris wheel problem. I think we did one of these before. Suppose a Ferris wheel has a diameter of approximately 520 feet. So let's draw my little Ferris wheel. I could do better on that. There we go. Technology. Then I'm going to do this. Straight line. Look at that. That's how bad I can draw. There we go. Work smarter, not harder. That's disgusting. Something to that effect. It was going so well. So diameter is 220 feet. So that's from here all the way down to there. Right? So that's this guy. That's 520 feet. It makes one complete revolution in 30 minutes. If you remember when I talked about before, that's a period. One complete revolution is a period. So I already know what my period is. My period's 30 minutes. Suppose the lowest car on the Ferris wheel is 5 feet from the ground. So the lowest car on the Ferris wheel, like this guy right here. That's my low car. That's 5 feet from the ground. Let the height of the top of the wheel represent the height at time 0. So this means we start right here on top. So this is where you start. I don't know why my Ferris wheel is a boat thing. write an equation for the height of the car h as a function of time minutes, and then graph the function. So they want me to write an equation and graph it. So here's my equation. Remember what I always say. We want to start at the middle. Figure out what the middle is. So, and how do we do that? Well, middle should be like around here. How high is that? Well, it's a couple things, right? It's half the circle. So if the circle is 520, so diameter 520, half of that would just be the radius, which would be 260. So that's 260. And then I got to add on the little, how far is it from the ground? So this would be 265. Obviously not drawn a scale. So that's my K. That's my middle. 265. Right? Because this is the middle of my thing. So that's the middle. How far is it? Well, it's 265 this way plus the bottom part, how far you are from the ground. So a total of 265. Now after I do that, I always like to find the amplitude. Well, the amplitude in this case is easy. It's spinning around the circle here. So it's just the radius. And we found that. It's 260. So there's my amplitude. The only thing I have to find now is my B. Remember how you find your B? It has to do with the period, right? Period equals 2 pi over B. And look, we have the period already. It's 30 minutes. That's all it takes to do one full revolution. So 2 pi over B equals 30. And I'm going to cross multiply. So 2 pi equals 30B divided by 30. I get B equals pi over 15 if we reduce it. So there's my equation. Y equals 260 cosine of pi over 15 x plus 265. There we go. I think they say want me to graph it also. Don't be too scared about that. It looks scarier than it is. What's my middle? 265, right? That's the middle. So dot dot dot, that's my middle. What's my amp? 260 each direction, so I could go 260 down. I'm gonna be 5 away. I could go 260 up, which would be some high number up there. So 520 plus 5, I guess. So 525. So it looks like that. My period is 30, so I'm gonna stop at 30. Let's say right here is 30. There's my little box. And then we have to draw a cosine. There you go, cosine. Remember, cosine starts at the amp, ends at the amp, halfway is the middle, halfway is the lowest. Sorry, just thinking of sine for a second. In between these two is where you cross. By the way, if I want to know what halfway is, well, half of 30 is 15. So you get that, and then we get something like this. So that's how the thing goes. And if I ask a question like, what's your height at, I don't know, 5? Well, there's 5, just follow the graph. Whatever that is, that'll be your height at 5 minutes. So stuff like that. Next, we're going to do some more graphing. Find the amplitude of each function, then graph the function. So this first one here, my amp is 2, right? It's the number in front. Remember, amp is always positive. Even when it's negative, it's positive. Negative lets you know to flip it. Period's 2 pi over b. My b here is the number next to it, so 2 pi over 3 is my period. So we're going to start at 0. My period's 2 pi over 3, so where's that at? Right here. That's going to be a small period. And my amp is 2, so we go 2 up and 2 down. So there's the little box. We're drawing sine. Remember the way sine goes. Sine starts in the middle, end in the middle, halfway. In between these two is your highest. In between these two is your lowest. So like this. So it's like that. And again, if I want, I could do another rotation. So it'll be about here. I think this one doesn't say fill the whole grid, but you could if you want to show off, show your skills. So to that effect. But again, in this case, it just said, it didn't say anything, so you just end right there. The next one, amp is 1/2, right, so number in front. Period's 2 pi over b, which is 2 pi over 2, so just pi. So 1/2, oh, that's gonna be bad. Let's cheat. Let's say this is 1 up there, so this would be 1/2. This is -1, this would be 1/2, right? Work smarter, not harder. So this would be my 1/2. Highest I could go. And down there's the lowest I could go. My period's pi, so right here is where I'm going to end. We're going to start at 0. So this is the cosine graph. You want to start on top, and on top, halfway is where you cross. Infinity these two is your height. In the middle, infinity these two is your middle. So like that. Again, if I want to fill the whole grid, just do another pi. So it'd be kind of like this. So there you go. All the moving ones now. So this one moves left and right, so that's a phase shift. So we're gonna start sorting differently, not at 0. So it's kind of start just normal. My amp is 3. My period's 2 pi over b. I don't have a b in this case, so my b is 1. So just 2 pi. Phase shift, 2 pi over 3. Inside opposites, so negative 2 pi over 3 actually. Inside opposites, we're going to go to the left. And there's no vertical shift, so we're starting at 0. So let's talk about the starting value. Starting value is always a phase shift, so negative 2 pi over 3. Plus a period, which is 2 pi in this case, over 1 I'd like to do. With the atom, just add fractions, common denominator. So 3 over 3 makes this a 6 pi. So I get 4 pi over 3 is where I'm ending. So let's mark down the board. So negative 2 pi over 3 is over here. We're ending at 4 pi over 3, which looks like it's over here. I started at 0. What's my amp? My amp is 3, so I could go 3 up. So this is the highest I could go, and I could go 3 down. So this is the lowest I could go. So there's my box where I'm going to draw my sine function. I should probably done this. My new middle, I don't have a new middle, 0 still, and then highest value is 3, my lowest value is negative 3 because of the amp. Anyway, so this is the box we're going to use. And we're doing a sine function. So start at the middle. And at the middle, halfway. Now if you're not sure what halfway is, most of the time I just eyeball it, but if you want, you could get the starting value, any value, add them up and divide by 2. That still works. In this case, I'd get 2 pi, negative 2 pi plus 4 pi would be 2 pi over 3 divided by 2. Be 2 pi over 6 or just pi over 3. Again, most of the time I just eyeball it. So 2 pi over 3. And again, it's a sine function, so between these two is my highest, so halfway. Again, you can eyeball it or just add them up and divide by 2. And you get something like this. Oops, it's an actual graph. And it goes on forever. Just like that. Should have been a little lower. Okay, the next one. So we have to go left, right, and up and down. So it's both a phase shift and a vertical, a new middle. So I always like to start a new middle. I think that's the easiest part. So my new middle is 2. It's my vertical shift. So what? And then you add the amp. So my amp is 2. So I can go 2 up, get 2 above that. So 4, and I can go 2 below that. So 0. Actually, I think a lot of times it's easier on the graph. So right, that's my new middle is 2. And I could go 2 above that because the amp. So up 2 is up to 4. I go 2 below that. So down to 0. Okay, amp, I should fill these out before I forget. Period, 2 pi over b. My b here in this case is 2. 2 pi over 2, so pi. My phase shift is inside opposite, so pi over 3. Positive pi over 3. So that's where we're going to be starting. Let me write that on the graph so we know. Alright, so that's my starting mark right there. I'm going to start at pi over 3. And then where we end, we just add the period, so pi over 1. Common denominator, 3 over 3. So that's like 3 pi plus 1 pi, which makes it 4 pi. So we're going to stop at 4 pi, which is right here. Alright, so here's my box right there. Right, we're starting at pi over 3. We add a period, we get to right here. And that's my box. We're graphing cosine. So as we know, cosine starts on top. Right, make sure you start the phase shift, not the origin. So right there, we end at the same spot, halfway between. Look around there, if I estimate. A little more in the middle. Then halfway between those is right across the middle. Across the middle. There is my graph. Like that. It's a cosine graph. And again, if I want to, it goes on forever. On both directions. Something like that. Arc length. So key to this is using formulas. I will give the formula. The form for arc length is O equals r theta. Only problem here is theta has to be in radians. So if you're using that formula, it has to be in radians. So what's the length of the arc below? Well, luckily they give us radians and they give us the radius. So arc length is just going to be 15 times 8 pi over 7. whatever it turns out to be, some number. Let's go to the next one. It's another, like, this is like the Ferris one, which is not a Ferris wheel. So same concept though. The water wheel has a diameter of 20 feet. So here's my water wheel. That's 20 feet diameter. It makes one revolution in 45 seconds. So remember, anytime I say that, that's just your period. So I know my period equals 45. Let the height of at the top of the wheel represent the time at t0. So right here, be when t is 0. Just like the last time. Write equation for the height of the point h in the diagram below as a function of time. I just realized they want h and t, so I should change this to h and t. I did not do the first way I should have. But again, it's the same. Everything else is the same. Anyway, let's do this problem. How do I always start it? I always start with the middle. Right, let's figure out what the middle is. Right here for my k. Middle should be right there. So there's no like height, it's just the circle. So that's my middle. So how high is that? Well, if the diameter is 20, it's 10 in each direction. So this is 10 and this is 10. Makes my height 10. Right, so if that's my middle, what's the amplitude? Well, here's 10. I could go all the way up to 20, so that's a distance of 10. Go down to 0. So the amplitude is also 10. Look, we're almost done. All I gotta do is find my period. And luckily, they told us. 1 revolution is 45 seconds. So my period equals 45. Period also equals 2 pi over b. So let's set that equal to 45. Cross multiply, do a little math. 45b divided by 45. I get b equals the disgusting 2 pi over 45. So there we go. Y equals 10. Cosine of 2 pi over 45. X plus 10. And actually, I'm going to change it this time because I didn't do it last time. They want it in terms of h and t. T is always like the x value. So this should be t and this should be h. The height equals 10 cosine of 2 pi over 45 t plus 10. Would I mark you down if you put x and y? Not really, because you have to just the problem, but that's the more correct answer. Find theta. So this is a right triangle, so you use SOHCAHTOA. So all we gotta do is able to list out the sides. So this is opposite, because opposite the angle. Opposite the right angle is hypotenuse. So that's this guy, and the missing side is adjacent. We have adjacent and hypotenuse. SOHCAHTOA. A and H is ka. So cosine of my angle equals adjacent over hypotenuse. Remember the way, since we want to find the angle, the way you get rid of cosines, you do cosine inverse. So you do cosine inverse on both sides. When you do this, you generally want in degrees because it'll give you an answer you're used to. Well, if you don't have a calculator, well, you can just leave it like this, like I'm going to do. So, same with earlier. You just leave it like that. That shows me you know what you're doing. So that's fine. And I think that's it. The rest are just notes. It's my little cliff notes of the chapter. So there you go. Remember, 12.9 won't be on the test because we didn't have a chance to get to it because of, stuff. Anyway, there we go.